Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hello, my name is Lee Dirks. I'm the Director for Education and Scholarly Communications here in MSR. And I'd like to welcome you to this instance of the Speaker Series, MSR Speaker Series, where we're very proud to welcome Dr. Miguel Nussbaum. As you can see, he's from the Catholic University of Chile, and he will be here to speak about 15 years of his experience in research in classroom technology uses and applications. Miguel has, I think, a long and proud history of working with Microsoft, with various groups, with MSR specifically, also with Partners in Learning over the last 6 or 7 years, as well as the last 1 to 2 years with the Unlimited Potential Group. So I think his work is very influential and very impactful, and we are continuing to work with him and engage with him moving forward. He's actually recently joined and is in partnership with the Games for Learning Institute that we announced last year. So I think his bio was in the actual talk. I wanted to add the Microsoft specific bits there, but I will turn it over to Miguel to begin his talk. One other word of introduction, Miguel said we have more than enough time, I think, for his talk. We have an hour and a half allocated. He said he would be very happy to take questions from the audience during his talk. So if you feel so inclined, don't wait until the end. Definitely interrupt him and ask questions, right? All right. Dr. Nussbaum.
Thanks, Lee. I'm really honored to be here. Thanks, Lee and John Nordlinger, for inviting me. So let's start.
I might need to pull the microphone off, and we just need this part back up here.
Oh.
Yeah, that's good.
It's fine. So I said it's an honor and a pleasure to be here. Thanks for inviting me. The first thing we have to see is what's our 21st century student? What does it look like? He's hyper-connected, as Time mentioned it a couple of years ago, and that's not only happening in the US and in developed countries. You have to think that I'm working in Chile, and my main aim is the underdeveloped countries, because everybody looks where money is, and I look where the money doesn't is, and our students are also very connected. In Chile, there are more phones than people at this time, and if you go to very poor schools, at least 1/3 of our students in the poor schools do have a cellular phone. New codes. This is very nice. You haven't seen it before. It's worth looking to it. My summer holidays were a complete waste of time. Before, we used to go to New York to see my brother and his girlfriend and their 3 screaming kids face to face. I love New York. It's a great place. And that's real. It happens. Schools doesn't address it, but still real. They're multi-process. They can do a lot of stuff simultaneously. They're visual. If you ask a teenager about a concept, he's not going to look to Wikipedia or Google. Mainly what he's going to go is to YouTube and ask YouTube about a concept. And that has enormous implications in knowledge construction, because at least my generation was based on written symbols, and my knowledge construction was on knowledge symbols, on written symbols. But this generation is building now knowledge on images, and this makes a complete difference. And they're not only visual, they're also real time. The phenomena of World of Warcraft is something we cannot forget. And they're not only interactive, they're only interactive in their bodies. The Wii of Nintendo, and now Natal, is really making a difference, because our interaction won't be anymore about our brain. The interaction will be our whole body. Meanwhile, the school is still the same. So in 1996, when my daughter was in 5th grade, I said something has to be done. And I applied to a grant of the Chile government saying I want to bring games into the classroom. And at that time, I used the Game Boy of Nintendo, basically because it was a very cheap platform. The basic platform costed $37 at that time. The cartridge cost like $10 each. So we did our own cartridge and our software. And what we wanted to do is to bring technology inside the classroom. We wanted to change the classroom. So we put the Nintendos inside the bag and give each child a machine so that the children could work independently and interactively, all at their own pace, in a sense that they were not only working interactively at their own pace, but also with games. We really developed games as the ones that were at this time common. In this case, they have to sort numbers, and there was a magician that had to take the numbers in the correct order, and there were antagonists and things like that. And here's another game where this is a temple, a Greek temple, and he has to go through a different antagonist. This is a monster or whatever. And then he has to find out if the temple, this is sombrero with an S, and he has to find if it's right or wrong, and if it's right, come an angel, and whatever. So games like the games that were at that time. But the difference was these were really educational games. What happened was that once we worked with 6 schools, with at least 500 kids, more than 500 kids. There's a very nice paper in Computers and Education about this experience. If somebody's interested, I can send it to you. And we got statistical significant results and also qualitative important results. But the Ministry of Education say 1998, games in the classroom, no way. So then came 2007. And in 2007, basically what happened is that we don't have anymore this classroom, but we have the same classroom. And the only difference is that these kids now have a computer in front of them. And this is even worse, because if the kids were not taking attention to the teacher before, they're taking less attention now, because now they're surfing the internet, if there is an internet available. And if there's no internet available, there's so much fun doing anything else than listening to the teacher on a computer that definitely they are having less attention than before. So the situation isn't better, it's gotten worse. So the point is, what can we do with this technology? And this technology has also come to Latin America and the whole world. In Uruguay, they have bought 180,000 machines. Peru bought 50,000 machines. Chile is buying machines. Everybody's buying machines. But the point is, what are we going to do with these machines? And my point of view is that we really have to transform the classroom experience. We have to transform what a teacher is doing. Today, we have a teacher that's irradiating with knowledge, which is a commodity, to passive students. And what we have to do is to really make the students work and be the students the first person in the classroom. And that's what we did at the beginning of 2001. When the first Pocket PCs appears with Wi-Fi, that was 2001, what we did was collaborative work in small groups inside the classroom. And basically what we wanted was to use the curricula as a Trojan horse for the development of social and communication abilities, and have the teachers really for what they're really good for, that is, mediate those students that really need it and define the objectives of the classroom, as you see here in the last part of the movie. When you have collaborative one-to-one, what means collaborative one-to-one? One machine, one child, and also collaborative. First thing is that the groups we always work with are groups, small groups of 3. What we have seen, and we have studied it empirically, is that when you have a group of students, just a conversation. When you have a group of 3, a momentum appears in the conversation, and the children have to learn to converge. When you have 4 or more, there are too many viewpoints, and what happens is that those students that are socially capable take control of the group, and those that are less capable just don't do anything. So 3 has shown to be the best size of group. Now, what we also do is make them work randomly. That means that every time the groups are formed, these groups are formed randomly in such a way that the students have to learn to work with kids that know more or less than them and kids they like or dislike. I have a nice anecdote in Wolverhampton in the UK where a well-known racist boy came to the teacher and said, I'm not going to work with this Pakistani girl, you know that very well. And the teacher said, there's nothing I can do, you know how the groups are formed, you know that your ID is already on the machine and you have to work with her, that's it. So the boy knew the rules, came back and worked with the girl. He didn't like the idea, but he did it. And when the activity finished, he came again to the teacher and said, you know, it wasn't so bad to work with that girl. And that makes a hell of difference. So what you have here basically are 2 networks. One is the social networks, where the students look to them face to face, where the students interchange ideas, where the students really work out their problem. And the technological network, which has to be as ubiquitous as possible, as seamless as possible, in such a way that the technology just supports the social network. The key element is the social network, and the technological network is just the support for the social network. Why collaborative one-to-one? First, a space where all actors participate. What you see here is a movie of children at the end of first school year. That means children which are 6 or 7 years old. Interesting is that girl that looks to the camera, but she doesn't care. She's so involved in what she's doing, and what she's doing, she's discussing about the math problem. So she's not talking about TV or Michael Jackson. She's talking about math. And she's completely involved. And all of them are involved. And all of them are involved because basically the software is done in such a way that there are interdependence, there are mutual support, and accountability. Everybody is responsible of their work. Building a communication space. This is very nice. Look to this girl. She's verbalizing something, and the other don't get the point. So she uses her machine to show what she wants to stress. And then look what happens. The other 2 peers look to their machines to compare what she had with what they had. So here you see clearly how the technological network supports the social network. The learning occurs at the social network, but the technological network really supports that learning. We ported this software to XP machines. Here you have on the classmates. And what happens with netbooks is that they're not seamless. They're not as ubiquitous as the Pocket PCs are. Look what happened here. This girl, to see what the other girl has to do something which is really not nice. What you want is that the technological network really supports in a seamless way the social network, and this is not the case. A very nice machine is the new tablet of the classmate. I don't know if you've seen it, which is like a big Pocket PC, and for me that's the best really platform I've seen for this type of work. Here, once again, you have the technological network, which is formed by a robot, the 3 Pocket PCs, and the wireless network. And what the robot basically is doing is moving in such a way that the girls have to draw a graph of distance versus time or velocity versus time. And you saw in the movie how the technological network supports the social network. Once the activity finishes, then they began to discuss in such a way that they really have to come out to a common answer in the way the software is built. Building a negotiation space. Once again, you see the children. These are the same children of first grade. How interconnected, how coordinated they are. And they have to negotiate the answers. Look how she's really dealing with the other pieces of knowledge, because the pieces are distributed between the different machines. And there's, of course, immersion. They really like what they're doing. Building a coordination space. This is very nice. This girl loses her focus of attention. Now comes this girl and says, hey, wait a minute. If you don't work, I cannot proceed. So please return and do your work. And she comes back. These are like gears that are interconnected. If one gear stops, the other one pushes it. So the software makes makes the group really coordinate. And in the back, you see the teacher that's helping a group that needs it at a time. The teacher. The teacher here, you see, is looking to a machine and looking to a group of students. The question that the teachers make herself is, who should I help? How can I know who can I help? And what you have to do is to really support the teacher. If you want that the teacher is an active mediator, you have to give the teacher the corresponding tool. And what you have here is the teacher's machine. In the vertical axis, you have the different groups. This is group 1, 2, and 3. And here you have the different activities. And what you can see here, so the color-coded, green means it's okay, yellow, they made one mistake, red, 2 or more mistakes. So you see here clearly that this group is not working, while group number 2 is fine. However, in question number 7, nobody did it right. Not only 2, but everybody. So there's a problem with the topic of question number 7 that the teacher should address at that time. So let's look to real data. I like this data very much. This is real data. You see here that in the group number 12, if I'm not wrong, what happens is that they have right, one mistake, right, and they work in the fourth activity. So what happens, they are very slow, but not only they're slow, but also they made a mistake. So definitely the teacher should address this group. On the other side, the last group is also interesting, because what you see here, that the number of greens and red are the same, and there's a lot of yellows. So basically they're working randomly, and they're very fast. So you see that this group is really not working, they're just guessing, and this group should also be addressed. So this information is online. This is real time, sorry, not online. This information is real time. The teacher can see at every instant how the different groups are doing and how the different subjects are doing. For example, look to these 3 questions. These 3 questions have some problems. They're not so bad, but at least at the end, the teacher should address these topics, because there are some kids that have problems with this. So this information really is available at any moment for the teacher and can help the teacher to mediate the corresponding groups and all the classroom for the topics. Also, this information can be uploaded to the internet in such a way that everybody that has the corresponding privileges can really see what happened with the different activities and different topics that's going on the school. We are working in Chile. We won in 2004 the prize of innovation in education of the Organization of American States. We have a project in Argentina, which was sponsored for Partners in Learning of Microsoft. We are in Brazil. We just started a project in Guatemala. It's not just, we had 4 schools in Guatemala, and last week the government accepted to make a project of 88 schools in Guatemala, which is now our biggest deployment. And we did a project sponsored by the US Department of Education with the Stanford Research Institute in 3 schools of San Francisco for teaching fractions. And what's very nice that 2 weeks ago, we got the Best Conference Paper Award for this work. And where I'm most proud is the work in Wolverhampton in England, where we work with the University of Bristol and the Guardian of London in the Tuesday educational magazine showed our experience, and they said John Galloway tests out the idea that comes from South America, not Chile, just South America. But that's fine. South America teaching the British how to make education. And when I began my talk, any questions up to now? I'm quite fast, so let's leave it at the end. Yes, yes.
I have a question, but kind of a little broad. In a sense, I think we're emphasizing a lot of the changing dynamics in the classroom, but at least from the example that I saw, I think that the teacher is very much in control, dictating the activities that students are going to be working on, right? So we have like a grid of activities, 9 activities that each group has to follow, either right or wrong or somewhere in between. And I don't know, when I start to think more in terms of mobile technologies in learning, I see that you can give more control to the students, right? I see a great opportunity for students to bring their lives to the classroom and vice versa in a way. In there, so I'm not sure this is something that's been addressed in there or not? How do you think about those issues?
I completely agree with you that still it's very classroom oriented. And it's classroom oriented in the sense of changing the classroom but still being inside the classroom and still following a curricula. We have had, and I mentioned at the end, a lot of our biggest problem are the teachers. Talón de Achilles, how you say talón de Achilles? Yeah, that is the teacher. Now, if you have to go small steps, and this is a huge step. And what you are addressing is a much bigger step. So if you go to the next step, they wouldn't even understand what you want, and they wouldn't do it. That's my impression. Yeah, this step is very big. And what we're doing in some sense is trying to go a little back, because bringing the netbook into the classroom is bringing a computer, because a Pocket PC is not a computer. Teachers didn't like the Pocket PC. Even I'm going to show you data in a couple of slides more that the Pocket PC is the ideal platform. But the teachers don't like it. They want computers. So we have to go with the teachers if you really want to change the classroom. For doing research, fine. And I'm going to show what I'm doing in research. I'm really doing at the end, I'm going to show you really Alice in Wonderland. But that's far away for the teacher, far away. But if you really want to go with the teachers, you have to do it in small steps. Yes?
The children have changed, and you want also the classroom to change. Do you also want the curricula to change?
Oh, that's a great question. You shouldn't have addressed that. Yeah, my dream is to change the curricula. I definitely think that we shouldn't. You asked it. You gave me the space to say it. I think it's ridiculous to teach logarithm in schools. Why do we still teach logarithm in schools? Why do we teach to factorize polynomial? What we should teach is how to model. If you teach algebra, you should teach really how to model and not how to solve, if everything can be found today in the internet. If you want to know what's the factors of q squared minus 1, just go to the internet if you don't know it. What's interesting is what you can do with q squared minus 1 and not how you solve it. That's really useful. And there you also do a lot of abstraction. So I personally would change completely the curricula, completely. But I'm not. But that's too far away.
I disagree a little bit. Like, I think children should understand how things are computed and even how their little pocket PC work. They're not just users. I don't think that's. I think education should serve more.
Well,
educating users.
Well, that's exactly why I haven't addressed that topic. Because if I open that topic, then nobody will hear me. So I just follow the curricula, but I change the way it's going to be taught. But I'm not saying, if you ask me what I think about the curricula, that's my opinion, yeah? But that's not what I'm doing in my research. My research, I really follow completely the curricula, because I know if I would change the way I teach and then change the curricula, I cannot find a school where I can really put my stuff inside. So I know that. But my opinion is this. So the point is, my interest is not really to solve the education for the rich countries. I'm much more interested in the poor countries. So a couple of years ago, I met Kentaro Toyama of Microsoft Research of Bangalore in a conference, and I learned the Multi-Point Sdk. And I was fascinated of it. Because what happened is that I saw immediately that we could do the same stuff we were doing with the Pocket PCs, but much, much cheaper on one PC and 3 mouse. And and that's like 3 years ago, I began working in the multi-mice. And what we discovered with multi-mouse is that especially for small children, and we have worked with kindergarten, 1st and 2nd grade, is that they work much better with multi-mouse than with Pocket PCs. And what happens is that small children in Pocket PCs have to build, everybody have to build the different pieces of knowledge that are distributed in different machines in their minds. And that's not so easy for small children. While when the information is in one screen and the focus of attention is one machine and not the different machines, makes life much, much easier for the small children. And what's also very interesting is that what happened to the teachers is the teacher liked much more working with the multi-mice than working with the pocket PCs. Because for the teachers too, going to help the groups and see what happened in different machines wasn't so easy, was some way awkward. But looking to one screen made the life also simpler for the teacher. I like this movie very, very much because what happens is that the children uses both hands. One hand for the mouse and the other hand for pointing on the screen. And on the other side, what happens is, I don't know if you saw here, that this child is trying to get the mouse of the other child because he just doesn't move the mouse. But he says, no, this is mine, it belongs to me. What you lose really in the multi-mouse is one thing. When the children work face to face, they look to their eyes. And looking to their eyes is something very important for human beings. This trust building. While they look to the screen, they don't look to the eyes. And that's something we really miss. And that's it. That's the price of it. Things we do here basically is that the children own their own objects. So the blue mouse has this object, the red mouse has these objects, and the yellow mouse has these objects. So only the blue one can select these objects. And what they have to do here is to sort these objects in an ascending way. And here is clearly a coordination and synchronization objective behind. And of course, accountability, because every child is responsible of what's doing. And at the end, what happens is that not one child is right or one child is wrong. The group is right or the group is wrong. Everybody is responsible. Immersion is something very important, that really children like to go and work with this. And also the teacher like it very much. Look really how involved they are in what they're doing. And that happens not the first time, it happens the whole year. And we've been working a couple of years with this already. As mentioned Lee, we're working with unlimited potential. So the next question was, can we go even cheaper? And then comes the massive multiple mice. And here is not one laptop per child, here it is one mouse per child. And what you have here, and we can work up to 40 kids now, every kid with his mouse, and what you have here basically that the children owns their own space. And in that space, they're working their activity, they get their own feedback, and they can work at their own pace. And it's really working extremely nicely. And it's very, very cheap. Just one projector, 40 mouse, one PC. Less than $1,000. And transportable to any classroom. That's it. So you see that here, the different working space, the addition here, the feedback, this is wrong, this is right, this child is sleeping, is doing nothing, and here's the feedback for the teachers and the whole classroom. What they did right, and if they did it wrong. So do you have both dimensions? The next step is, let's bring World of Warcraft into the classroom. World of Warcraft, as mentioned before, is a phenomena, and a phenomena that we cannot forget. Because what happens with World of Warcraft, that's a massive multiplayer online game where motivation is key and realism, persistence, quests, and interactivity are the elements you can play with. So we ask ourselves, can we do something with quests that's realistic and interactive? And what we did basically said, we don't want something massive. What we want is something for the classroom. And we don't want it online. We want it presential, inside the classroom, looking the children face to face. So it's a classroom, multiplayer, presential game. And what we did is here, you have 10 kids in this screen, it's moving fast to show. And they're all, well, here explaining what the game is doing, but basically each child is moving exactly as the same semantics, the same syntax as in World of Warcraft. Basically, you have lives, you have energies, you have characters, you have non-protagonic characters, and whatever. And what we achieved, in the next one you can see better the game. I hope here, wait. Here. We haven't gone yet to the school. This is just finished. So you see the different children and a different way of interrelating. I don't want to lose too much time, but the idea was to show that we're also using the multi-point SDK because basically all the children are interactive at the same time, 10 children. And our aim is to have 4 projectors, 1 to each wall, and have the whole classroom interact. But that's much, much more difficult because how do you really make quests where all the children interact and that the children can really coordinate? So it's not so easy. That's why we just started with 10 to really understand how we can do this type of stuff. And the last thing we're doing, I noticed this as Alice in Wonderland, is augmented reality and participatory simulation. Participatory simulation basically is a simulation where the character is the person that does the simulation. It's not that something happens on the screen. You are doing the simulation. I don't know if you know the work of Vanessa Colella of MIT of the late 90s, which was very nice. It was the simulation of a virus, and they used this tag where they really interconnected, and there was a technological network, clearly technological network made by these tags, and the social network where the learning occurred. Well, this same type of concept we want to use now for teaching, for example, electric charges. So what we do here is, I have to do it here, is first the children have to find out if they have the same electric charge. So they approach each other, and if the charge is different, it's a zoom out, they like going away because they repel. While if the charge is the same, it's a zoom in because the charges attract each other. So the children have to find out what the charge is in correspondence to the other peers. And then what we do is, with augmented reality, is a game where it's full of asteroids inside the classroom. And what they have to do is to move this asteroid following Coulomb law. And what you saw here is that this object is being repelled, is being pushed by the student that approaches the object. So the same thing has to happen with the asteroids. So in group of 3, they have to move around this asteroid to push it. So what we're doing then is that the children in small groups interact with these virtual objects in this virtual world. So what we're doing here is we go one step forward. And that's why I mentioned it like Alice in Wonderland. We're not working anymore with a screen. We are working now with a classroom and the virtual space. And the viewer for the virtual space, what we're using is the tablets of the classmate, which has a camera and has a big screen that allows you really to look to the different classroom. Because if you have a small screen like a telephone, it's too small. But if you have a bigger screen, just look in the classroom and see what's going on. What we have to go one step further, we're still using these awful tags. We want to use better tags. And we're working in the Games for Learning Institute, and Columbia University is still developing all the augmented reality platform. What have we learned all these years? First, if you go to schools or you talk to governments, their decision is about technology. What technology are we going to buy to put inside the classroom? And this is full of technology. And what we have learned, and I made an analysis of how do children react to the different platforms we have used. We have used pocket PCs, netbooks, and phones. We also ported the same stuff to phones with Wi-Fi. Our dream was to use phones with Bluetooth. However, we haven't really got to solve how to have a good, reliable, and fast network in Bluetooth. I think that's unsolvable. So we have been working with Wi-Fi. The bad news was that these phones were extremely expensive. These machines cost $500. It was the iMed SP5. But we just got new machines which only cost $100, which makes things much more reliable. We are now testing these new machines to see if the Wi-Fi is really reliable, and you can build a network for 40 children with using these machines. So we asked the children 3 questions. Where do you feel you shared more? On the Pocket PCs, classmates, and phone. There were 33 students where we made a study, and the children unanimously basically said we share more on the Pocket PC. In which platform you think you have a better work or you work faster? And they said there was almost no difference, but in the Pocket PC, they felt that the quality of the work was better. And finally, what do you like more, traditional classroom or technology-based classroom? There was almost no difference once again. However, the Pocket PC still is better than the other ones. So if you ask the children, they prefer the Pocket PCs over other platforms. But if you ask the teachers or the principals, they hate the Pocket PCs. That's not the machine for the classroom. So they want netbooks. Netbooks, they love netbooks because they're cheap. It's like a real computer. So that's not the point. Technology is not the point. What you should really address is what's the educational model you're going to use and what are the contents, what the curricula, what do you really want to teach? And what you have to understand is that when you have an aim of teaching a content or a skill, not every pedagogical model really fits that skill. So you have to find which is the best way of teaching that corresponding skill. Now, if you had a media, technology, whatever media you think, you have to understand that not every media really supports every pedagogical model. So at the end, what you have to do is to really understand what you want to teach, and at the end, select your media. And don't start with the media as happening today, where countries are buying hundreds of thousands of machines and then asking what we can do with these machines. Now, what we really want to do, as I mentioned at the beginning, we want to change the 19th century classroom. And we want to have a classroom that supports our 21st century student, as we saw at the beginning. We have today a paper-based classroom. If we could really change with the paper and pencil from the 19th century to 21st century classroom, that's fine. But we haven't done it, and we cannot do it. So the question really is, how can we really move from this quadrant to this other quadrant? What worries me, for example, are interactive whiteboards. That's my personal opinion. Because I think what happens with interactive whiteboards is that we're moving from this point to a point which is, of course, better than this one, but still we're teaching in the same way. Because interactive whiteboards, it's interactive for the teacher, but not for the student. The teacher is now very active, interacting with the internet, interactive with dynamic objects, or whatever simulations might be. However, the students are still completely passive. So my point is that we have to have active students. And the point is, how can we really get it? And my proposition is that with activities like the one I've shown, and in the netbooks, what you can do is not only do creative work, but you can have a window connected to the internet where you can ask the students to really find information on the internet or do some simulation work, and the result of that work really use it as input of the creative work. For me, this is really the 21st century. And then comes what I say is el talón de Achilles, the Achilles, yes, teacher training. That's really the biggest problem. And I would say what we have found that immersion and coaching are the key issues. Immersion, where the teachers really go and learn to use this, but you also have to coach them. You have to go inside the classroom and show how you use this technology and be an active mirror in the sense that you really help them to improve what they're doing. And that's very expensive. To do coaching is very expensive. And on the other side, to change the way you teach requires time. And time is something teachers don't have because the government doesn't pay for that time. For example, in Wolverhampton, where the experience was extremely successful, what happened is that the teachers arrive at 8:39, the children arrive at 9, and the children leave like 3 o'clock, while the teachers leave 5:36. So the teachers are there 9 hours, the students 6 hours, so the teachers have 3 hours every day for preparing themselves. This time is not available in Chile and in non-Latin American country. So if you don't have available extra time, how are you really going to change the teacher's way of doing things? And I would say that's really the hardest part. And at the end, if you don't have a vision, if you don't understand why you're doing the stuff, why you want to transform it, and where you want to reach, you don't know what's the way you have to travel. So you really have to have a vision. You have to have aims, so you really can define your project. So you have to start from the vision and at the end define what hardware you want. And not start with the hardware and say, what can we do with that? As it happens today massively. So conclusion. I like paper and pencil perhaps because I'm 50, but I think paper and pencil will be still there. Even the tablet has a virtual paper, but paper and pencil is so ubiquitous. However, seamless interconnected technology really makes a difference inside the classroom. And the second thing is that we have to understand that there are different pedagogical projects for diverse realities. There's no one solution. There are different necessities and there are different solutions. And we have to understand which solutions are for which problems. There's no one silver bullet. That's it. So now let's go to the questions. I hope there is one question. Yes. Thank you very much. Let's go behind and then.
So, do you have an attempt to bring the content creation to the teachers themselves? You know, they will be responsible for creating the contents for your games and the applications and so on, instead of just being the mediators of that?
And we have authoring tools. However, the teachers don't have time to train themselves, much less time to prepare materials. And the other thing what we have seen, and that's not only in Chile, we have experienced in several countries, is that if you don't have very well-defined structured lectures where you say, in this lecture for this aim, use this material, they won't make it. Because what we have a database of now 15,000 different activities, structured with different goals and through the curricula. And the idea is that the teacher really selects what he wants, but that's time. And if we don't structure them and give them, this is for this lecture, they just don't use it. So the ideal is, and we have editors where they can change the activities a little bit, put different names or whatever they want. They don't have the time. They really don't have the time. And even in the US, because we worked 2 years with 3 schools in San Francisco, in the US they didn't prepare the materials. We did it. We definitely did it. And we did it from Chile more than from the US.
So what happens, for example, when you have too many red squares in a given topic where the teachers, they need to address that? So how do they typically do that? Should they just give the feedback back to the content creators and then in the next slide?
No, the problem is not from the content. The problem is basically if you have red squares because the students didn't, it's not the problem of the question. The question is okay. The problem is they didn't understand the material. They didn't understand the topic. And it's not the problem of the question. Because the easiest, and it's very interesting, the easiest is to change the question. And that's what they do. They make easier questions. And that's what happened. We have seen that. Because in our database, the database was targeted just for the average. And it's not a comprehensive database because we have math, language from 1 to 12, science from 5 to 8, chemistry, physics, and biology from 9 to 12. And that's around 15,000 topics. And our impression is that it's comprehensive, but it's not deep. It's just general. It's not comprehensive. It's breadth, but not depth. So to have really depth, I would say it should be at least 3 times as big as this. So you would need at least 50,000 to cover all these topics through all the classrooms. So we leave it open. So what we discovered was the few teachers that really did some contents was that in the private schools, because we also work with private schools, they found our database too easy. And in the public schools, they found the database too difficult, and they make it easier. It's no problem to make it more difficult. The problem is when you make it easier. So they said they did exactly what you said. Oh, it's full of red, so let's make easier questions. But that's not the solution. You were first.
So you mentioned how 3 children was a very good group size, but you also showed the example of the 40 children working together. I was wondering if you could talk a little bit about how that experience was different in terms of how the children participated and how well they did, and was it difficult to design an activity for engaging all 40 of them together?
Yeah, the massive multiple mice, the aim is to bring technology and interaction where no computers are available. So collaboration is still not an aim there. I have now 2 master students working on that to see how we can really do collaboration in a system like that one. Because what we really want to do there is to give interaction and personal feedback to the students. So there we haven't solved the problem of collaboration. While in the World of Warcraft type of activity, where you also have a lot of children working together, there the quests are built in such a way that the students really have to find groups of 3 to solve the quests. Because it's made that way. Because we really want that the groups are small so that they can really interact and talk and discuss. But in the other one, the massive multiple mice, there's still no collaboration. It's an aim to find out how to make it. But it's an open-up problem. I haven't solved it. I don't know still how to do it. Yes?
I agree with you that it's the professional development issue of the teachers in any school change. So are you working on technology-enabled coaching or working with anybody on that end? So that, because you can't just train the teachers once and have them progress with this.
We haven't really had funds to make technology-enabled coaching or teaching, whatever. We just make classical face-to-face teaching and then coaching. But that's very expensive. And we haven't really solved the issue because our project is expensive because of the coaching. Because we don't want really to make a project where we don't are sure that we're going to have good teacher training, because it won't work. It just won't work. And we haven't solved it.
So, as you mentioned, before we decide about we choose the technology, right? First, we have to think about what to teach or what to expect students to learn, understand what's the right pedagogy or approach for that, and then figure out what kind of tools would support that, right? And then one could also imagine that for different students, you might need a different kind of interaction or different approaches. There's some ranging there. But assuming that there's this diversity in terms of content and styles and etc., what kind of technologies? Like if you have like a unlimited budget, right, and you could implement something like a hardware piece or software piece, what would you do?
Unlimited budget. Well, I am fascinated with Alice in Wonderland. I think that discovering a virtual world inside the classroom can be really fascinating. So if I would have unlimited budget, I would go in that direction. That's, for me now, the most interesting work I'm doing.
So you do like a virtual space?
A virtual space, because this idea of having a screen is still back of the 70s. We're still on the same model. But with Alice in Wonderland, where you're discovering with a screen, small screen, this virtual world changes everything, changes really everything. And even more, I saw it some time ago in Europe, 3 weeks ago. I couldn't believe it. It was only 30 euros. I should have bought it. It was a T-shirt with a real clock. It was a clock on the T-shirt. It was a T-shirt with a clock. It was only 30 euros and a real clock. It was working. It was the same time. Yeah, and wait a minute to see how it changed, and it changed. Yeah, so this is a real screen. So you have screens everywhere. You can see inside the belly, you making Alice in Wonderland. I think the next step is really Alice in Wonderland. That's unlimited budget. I think that's the future. I'm a little how you say.
And then you leave kids alone there?
No, teacher. Always the teacher, because in Alice in Wonderland, the teacher has also his own platform to see how the students are doing. For example, when they define if they have the same or different charge, the teacher sees the matrix of the different kids and know who did it right, who did it wrong. So to go to the children and make them look again why they did right or what they wrong, what they didn't understand. And when they're working with the Coulomb law, which they don't know is really the Coulomb law, because they're playing with these asteroids, trying to pushing the asteroids, but it's really Coulomb law. And the idea is to transfer the Coulomb law. And the teacher should have explained before the Coulomb law, and now they are playing with the Coulomb law. And the teacher should see which students are really making it and not. And the teacher has his own tool to see what's going on in the classroom. So the teacher for me is very important, really. I think that the teacher is key. Somebody has to be a mediator. Somebody always, if you think in Vygotsky, there's always somebody that helps us in the zone of proximal development. So the teacher is that person. Or a very intelligent tool, but still that's very expensive for me. Yes?
Have you looked at, so the Pocket PC tool that you have with the grid of questions, have you looked at adaptive learning at all? Say a group is doing well, give them more challenging questions for questions?
Yeah. For example, what we are doing in this massive multiple mice with the additions is we are doing now with an expert the whole tree, how to start from basic arithmetics to what the aim at the end is, and have a tree so that it's really adaptive to the children. And the child, when it finishes the lecture, the next lecture, he continues at the same point where he stopped. So that's really adaptive, and each child can really work at his own pace. And the teachers get feedback how the students are doing. So the teacher should address those students that are much slower and are progressing in a different pace. Yes?
I heard some opinions of people saying that computer games are nice for the children to learn concepts, but actually they're not that good for them to learn large amount of contents. Just like to know your opinion on that.
The problem is, there's a point here. An activity takes a long time. For example, this game, which I just showed a little bit of what type of World of Warcraft, which is an ecology game, it takes an hour and a half, the whole game, because first there's a tutorial to learn the game, and then they have to make mistakes until we get the game, so it takes at least 1.5 hours. And that's expensive. It's 1.5 hour game just for 1 or 2 concepts, and that takes time. So that's the price for it. But at the end is today, for example, electric charges. Of 100 people, 1 understands electric charges. So there are two possibilities. Or you just don't teach electric charges because you don't get the point, or you teach less and you teach it in the right way. So, for example, the activity of electric charge will take at least 1 hour and 90 minutes. At least 90 minutes. And that's time, because that's after you really teach the concepts, then you begin to play inside the classroom. This was not really I would say, with the Nintendo experience was differently, because with the Nintendo, instead those children that had the Nintendos, what happened was that instead of doing exercises with paper and pencil as they usually do inside the classroom, they played with Nintendo. So it was cheap. It was the same time. And this was a very successful experience. The experience finished when the Nintendo died, because the schools that had the machines, they use it and use it and use it, and then the Nintendo dies, and it was like 5-6 years. And then it died. Because we made one big mistake, really one big mistake with Nintendo. We developed all the software in assembly language because it was for the Nintendo. So it's no portable. That was a terrible mistake, but we had no other solution at the time. Yes?
Back to the slide where you had your long-term vision going down to. So can you explain to us what is the vision and educational model that guides your research?
My vision?
Yeah.
Oh, my vision is to have an active students inside the classroom. Because the classroom, from my point of view, I don't think the classroom will disappear. Because the classroom is good for developing social abilities, for developing communication abilities, and a place where the parents rely that the students are going to be with other kids. So there will be always a classroom, but make the classroom effective. So how do you make the classroom effective? Making the child the first person in a classroom and not the third person. Today the child is the third person and the teacher is the first person. I don't want that the teacher is the third person. I want that the children and the teacher are as important, that both talk a lot, that both are active. Because our kids are not active in the classroom. It's so boring to be in the classroom from 8 to 4. It's extremely boring. They're doing nothing. And giving them a computer just don't change it. It just doesn't change it.
So
I want to show you, just go ahead. I want to show you a joke. Yes? Yes, go ahead.
Oh, well, I guess so. Then is your view that those pedagogies that use small group activities without any technologies, let's say, you say so you're kind of espousing those frameworks and using the technology to say, hey, these small group activities are hard to implement, or nobody implements them, but everybody wants computers, so let's put computers in there and kind of use that as a Trojan horse to put these small group activities into the classroom. Is that kind of what you're saying?
No. The Trojan horse is basically that I'm using the curricula as a Trojan horse. Because as she asked about the curricula, I don't believe in the curricula, but still use the curricula. They want that I teach curricula, I teach curricula. But my aim is the developing of social and communication abilities. Because our kids don't know how to relate. In schools, they don't teach them how to relate, and they don't know how to verbalize. And it's a problem in the US, and it's a problem everywhere, that children don't know how to verbalize their ideas. And that's really important today. But if you don't talk in the school, how can you verbalize your ideas? You don't have a space to verbalize your ideas. But when you do collaborative work, you have to verbalize your ideas. Now, there's a point. What is collaboration? Because I've seen, and I mentioned to you before, a lot of people saying this is collaborative. Not because you're putting a lot of mouse inside one computer and you're using multi-mice, this is collaborative. For me, collaboration occurs when first there's accountability. Every child has to be responsible of their work. There has to be mutual interdependence. So my work is related with your work. So you remember that girl? If you don't work, I don't work. And second, there has to be mutual support. If I'm stopped, then you help me, or you help me. That's collaboration. Not just not moving mouse around and everybody does what he wants. As a lot of software which says it's collaborative and it's really not collaborative. Let me show you this joke. Here you have another photograph. I don't use it, it's too dark, but it's a very nice. Can you see it? Yeah, you can see it. It's a huge classroom full of students with a Apple computer. You see it? Can you see it? And I found this joke. Just read it. Can you read it? That's what's going on. So they're not there. They're even less than before, as I mentioned it. And this is true. That's happening. In a classroom like this one, of course this is happening. So why are you giving these kids a machine? You're not solving anything. You're not changing anything. Yeah, they're less bored. Of course they're less bored. But they're not learning more.
They're engaged by other things.
Yeah. So you're not solving the educational problem here. You're solving the boring.
Maybe asking was whether these more involved activities that you're having the students do on the what's it called, Pocket PC, for example, have you also had them do similar activities, paper-based, but activities that require active participation in groups, and sort of what's the difference between doing those activities on paper versus on the computer? Are the students more engaged, or do they learn better, or do they learn different skills?
Since you asked for it, give me just 10 seconds to find it, because these videos were really part of a PhD where we compared paper and Pocket PC based activities, and I hope they're here so I can show you really. Here they are. So for example, here the girl has pieces of papers, and she has to build the same type of stuff we did with technology. And what happens, this is a group of 3, and she's working by her own because the other one just doesn't care. And the teacher doesn't have time because there are 40 kids there. The teacher's looking for one group, but not 10 or 12 or 13 groups. So she does everything by her own. So that's not collaboration. She's learning. And there's no feedback. She doesn't know if she did okay. And the teacher has no time to look for this if this was done in the right way. So there's no feedback. And then you see what happens here. Let me see what happens here. Well, that's a computer lab. The same thing what happens, what I show you with the netbooks. The best way to do communication is with seamless machine like tablets or Pocket PCs. Yeah. Well, the more examples of the same, you saw this already. This is very nice. This is negotiation. Look, this is negotiation. Yeah. And this happened. We didn't pay for this. We got it for free. Yeah. So we really studied. They're negotiating. Yeah. So we studied it was a whole month, and we have a paper of this. So if somebody wants my paper, just give me your card or your address, and I send you all the papers. This is terrible. This is just terrible. This is my favorite but depressing, my most depressing film. What happens here is that here you have the board where they have to build the words, and here you have the pieces they have to cut for the words. Now this boy, which is the socially most powerful and the bullying one, says, okay, give me the pieces to me. I'm going to show you how to do this. Then these 2 boys stand up and say, hey, wait a minute, and look to this boy, which is the little poor boy. So this is the introduction, and leave it by your own. So he takes control. Now comes these 2 say, wait a minute, we want this back. Why do you have control of this? It belongs to everybody. It's group work. Why? And say, no, 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 no. And now he makes physical pressure. You see how he's doing physical pressure? So he gets them back. But this poor boy say, hey, I also want it. But he didn't make any pressure. So he say, no, no, no. I can bully you. So, no, no, no. I'm not going to give it to you. No, no, no. And now he says, if you don't give it to me, I go to the teacher. So he goes to the teacher, and before he goes to the teacher, look what happens. He throws it to the bottom. You see, he throws it. And look, how he's being humiliated in front of his peers. And this happened really. This is real. This is group work. So negotiating and bullying other peers.
Do you find that the Pocket PCs, obviously the Pocket PCs can enforce rules for equal collaboration?
Yes.
Do you find that the students are more reluctant to actually physically take someone else's?
They never took the machines of the others. As they don't take the mouse of the others. It belongs to me. It's my responsibility. We really didn't see never that somebody took the machine of the other and just, I'm going to do it for you. No, we haven't seen that.
And probably in the software itself, we can enforce more rules that are hard to enforce just by using ordinary media like paper and everything. So might be an advantage there.
And we have been working a couple of years. This project is now, we started 2003 in the classroom, so 6 years. And we haven't really seen nothing like things we have just shown you. Let me see what else I have here. No, that's the movies I have. So that answers your question, yes? So we did the study.
Does your business model requires you to have the government as the big sponsor of the initiative, or were you able to articulate some partnerships with the private initiative?
Well, that's a very good point. Up to now, we haven't been really, well, I'm a researcher. You've seen my interest is in research. I'm thinking in Alice in Wonderland, yeah? But on the other side, I try to really make this happen. So with the support of Microsoft too, we're trying to make a startup which has been extremely difficult. Extremely difficult, first because teachers. Second, because it was the platform. But now with multiple mouse, it isn't the platform anymore. However, I would say the biggest problem has been that if the government doesn't make the decision, the schools are reluctant to really make this change. Because they have so many problems, and this costs money because of the coaching, and it's not cheap because coaching is expensive. So it hasn't been really easy. So what I mentioned that in Guatemala we have now 88 schools. This has been our biggest success up to now. In Chile we have 80 schools, but that one country just buys 88. In Chile, it might be that at the end of the year we reach 300 schools, but still we are in the middle of it. And for example, in Brazil, we're working with Fundación Bradesco, which is a big foundation. They own the second biggest bank of Brazil. And they also we have been working 3 years for them. We just renewed the project. And they want the project now in all their schools, which is a big success for us. And they want to make now the connection to the government because they're very respected as an educational foundation. Because they love the multiple mouse. The multiple mouse, everybody that sees the multiple mouse loves it. Because it's cheap, and second, so simple to understand, because what happens with the pocket PCs, people don't understand what's going on. Because you really have to be there because it's distributed. The objects are distributed, and you have to really focus your attention on the different machines and think a little bit. It's not 1, 2, 3. You have to really look at it and understand what's going on. But on the screen with the multiple mouse, you get it immediately, and they love it.
So I have a question along the same lines, which is, when you say there's 300 schools here and 88 schools, how many of those is it just kind of, they tested it, or are those actual deployed, continuing to utilize this?
No, in Chile we have 88 schools which have been tested, and we have done, our biggest objective assessment, there are 2 objective assessments. One, which was performed by the SRI in San Francisco, which obtained statistical significant results, and we got this prize. And the other one is that in Chile, every year in 4th grade, there's a national test. And we use this national test for measuring our schools, and we had 5 schools in the north of Chile, Antofagasta. This was data of 2007, because it takes some time that we get the data, etc. And we compared these schools with the other schools of the same city, which are public schools, and we obtained statistically significant results. So I'm convinced that we are really not cheating nobody, that really children are learning. And one thing is they're learning the curricula, and they're also obtaining these social and communication abilities. Nobody discusses that the children really improve the social and communication abilities. That's a fact. However, that fact nobody pays for. They pay for the curricula, they don't pay for the other, which is much more important from my point of view.
Besides the learning the curricula and learning the social and communication skills, are you also trying to measure whether the students learn technological skills as a byproduct of using these things? Are they more comfortable using new types of technology on their own?
No, I really, it's nice that you mentioned it. It was not in my mind. No, I haven't really looked to it. If really it develops the technical abilities. I would say yes, because they have to, there's a model behind, there's a technological model, it's a user interface that follows some standards that we all have. It's not something very special, yeah. And I would say once you have this language, it's easy to go to other systems that follow in some way the same language. And with the multi-mice, what happens that the children really get very good, fine motor. Yeah. If somebody wants to see the multiple mouse, I have mouse here, so if somebody wants to see it, I can show it. Last question before I go? Yes.
I was wondering about your methodologies. I know you showed a lot of different studies here, but I wasn't hearing a lot about your methods of analysis or how you did it. Was it even qualitative, quantitative? Was it mixed methods?
Mixed method. First, we assess, for example, learning. We try to assess with tools that we don't do by our own, so to be as objective as possible. Yeah. So it's national tests, and with these results, we measure a control group that has the same characteristics, and we also measure internal control groups that are classrooms that don't use technology in the same school. So to really be as objective as possible. And in the qualitative aspects, we used mixed methods, yes. If somebody wants to, I have published a lot, so if somebody really wants to see my papers, just let me know.
All right, well, thank you very much.
Thanks for inviting me in your
you.
time.